Well, welcome to our lesson on transforming linear functions. In this lesson, we will be describing how changing the slope and the y-intercept will affect the graphs of linear functions, and we will recognize different types of transformations. So first off, we want to define what we mean by a parent function. A parent function is the most basic form of a function. When we're speaking of linear functions, we have f of x equals x, or y equals x is the parent function of all linear functions. All the other lines are transformations of this parent function. A transformation is a change of position or size, and the three types of transformations that we will be talking about are translations, rotations, and reflections. So let's start off with the simplest of the transformations, or translations. A translation moves every point the same distance and the same direction. We also refer to it as a slide. So we have a graph over here on the right, and the parent function is in blue, f of x equals x, and we have three other functions that are transformations of the parent function. Each of these three lines has the same slope, but has a different y-intercept. It crosses the y-axis at a different point from the parent function. So what happens with translations, if we change the y-intercept, if we make b go up, if it's a positive number, if we add a number to the parent function y equals x, then it translates up that many units. If we subtract a number, excuse me, then it translates that function down that many units. So you can see if we take away 2, we translate down 2. If we take away 4, it translates down 4. So if b increases, the graph is translated up. If b decreases, the graph is translated down. Rotations are transformations that look like a turn. The graph has the same y-intercept, okay, so it crosses at the same place, but the thing that's changing here is the slope. So our parent function is in blue right here, f of x equals x. But look what happens when we multiply by a whole number bigger than 1. That rotates this line counterclockwise. You can see if we make it even bigger, 5x, it rotates it even more. It gets steeper. And then if we have a fraction in front of x, that makes it less steep, and it rotates it the opposite direction, which is clockwise. So a fraction will rotate clockwise, a whole number will rotate counterclockwise. So when the slope is changed, it causes a rotation of the graph about the point 0b. You may recognize this point as the y-intercept. So that's what the point is referred to when we say 0b. And when we rotate about that point, it changes the line's steepness. That is a rotation. Finally, we have a reflection. A reflection is a flip about a line, and it produces a mirror image. If we multiply the slope by -1, that's the same as reflecting the graph across the y-axis. So if we start off with f of x is equal to 2x, and we just multiply that slope by -1, what that does to the graph, you can see this, is it looks like the y-axis is a mirror, and it reflects it about the y-axis. So when the slope m is multiplied by -1 in the equation, the graph is reflected about the y-axis. So let's go ahead and do some practice. It says graph the function f of x equals x plus 2 and g of x equals 2x plus 2, and then describe the transformation from the graph of f of x to the graph of g of x. So we're starting with f of x and we're going to g of x. Well, they have the same y-intercept, but they have different slopes. So we should be able to predict that g of x will be a rotation counterclockwise. So here I have each of those graphs. F of x equals x plus 2 is in red, g of x is in blue, and you can see that it looks like it was rotated counterclockwise. So when you want to write counterclockwise, you can just abbreviate that with CCW. If it's just clockwise, you write CW. Here's another one. F of x is x plus 4 and g of x is x minus 2. Same direction, so we're going to graph those first. So f of x equals x plus 4, we start with a y-intercept of 4, and it has a slope of 1, up 1, right 1. G of x has a y-intercept of negative 2 and a slope of 1. So we can see these are parallel lines, different y-intercepts. So if we start with the blue line, how do we get to the red line? Well, we have to go down 6 units. So that's a translation, and it's down 6 units. Number 3, we're going to graph f of x, and then we're going to reflect the graph across the y-axis. So here we have in this graph in red f of x, and then I graphed g of x in blue. We also need to write a function to describe g of x. So this one, g of x, would equal the opposite of x, right? It's just the slope times negative 1. In letter B over here, let's go ahead and graph f of x first. So f of x is negative 4x minus 1, and I thought I would do this one live with you so you can see how to graph it. So we start with the y-intercept of negative 1, and then we have a slope of negative 4. Well, remember we need to have two numbers, so I can go down 4, 1, 2, 3, 4, and right 1 to get another point, or I could go up 4, 1, 2, 3, 4, and left 1. So now we have 3 points on our line, and I just need to connect those together. So I'm going to cheat a little bit with my technology and go ahead and use the line function to draw this for me, and I need this to be a red line. So here we go. Let's connect these together. We'll start here. I want to go through that point. So our line should look something like that, and let me go ahead and extend this. Get that somewhat accurate so it looks something like that. So there's our f of x graph. Now we want to write an equation for the line that is reflected across the y-axis. So this will have a positive slope. So g of x, remember we only need to change the slope, would equal positive 4x minus 1. So it has the same y-intercept, but this time we're going to go up 4 and right 1, or down 4 and left 1. So that's our slope there. And then let's go ahead and draw a line again. This time I want it to be blue. Let's pick that blue. And this one goes from this point here all the way up to this one. So something like that. And so now we have two lines, and you can see that those look like they are reflected about the y-axis. And this would be, what direction would this be? On this one, we're starting with the red line, and we're going to the blue line, so this would be a clockwise. Whoops, I forgot to write my... So this would be clockwise rotation, right? Both of these are rotations. All right, sometimes we're going to have more than one transformation. And so we want to be able to describe whatever's happening here from the parent function. So first of all, we're going to start with f of x equals x. We're going to end up with f of g of x equals 3x plus 1. And then we'll describe the transformations on how we get from function f to function g. So first of all, we're going to take f of x and multiply it by 3. So that gives us this intermediate function, h. And so here are the graphs. So we're going to start with the blue function, that's f of x equals x. Then if we multiply by 3 to give us the correct slope, that would look like the green graph. Okay, but that's not our solution. We also need to add 1. So when we add 1, that translates it up. So we rotate it first and then we translate it. So the transformations are a rotation, and that rotation is counterclockwise. So make sure to include a description of which way it gets rotated. And it's translated. How far did it get translated? It got translated up 1 unit. So it's a rotation counterclockwise and a translation up 1. That'll do it for this lesson. We'll see you in class where we can do some more practice.